Wait, do you smell that?
Oh yes, actually I do.
It's quite pungent, isn't it?
Yeah. It smells of gas.
Chromatography.
Oh good.
Yeah.
It also smells of terrible jokes.
Yeah, and lack of material for introductions.
So let's skip over that. Let's teach gas chromatography.
Right, so in the last video we did thin layer chromatography, which is similar.
Yep, similar idea, the separation and the analytic technique to find out what might be in a thing.
Yeah, this time, as it suggests, gas is involved.
Yeah, so it's for volatile things, things that can easily become a gas.
Yeah. And our mobile phase is always a gas.
Yeah, and it has to be an inert gas.
It does.
You'll see why in just a second. So something like your noble gases or strongly bonded nitrogen. So nitrogen.
Yeah. So let's go for an example. We have here a lovely drawn chromatograph.
a thing.
A thing.
So let's go through what all the things are.
Yeah, so at the far left we have a cylinder.
Yep, and this
contains
It
contains our inert gas or our mobile phase, remembering that that is the thing that moves through our stationary phase.
Here we have some sort of injector. This is where the subject we're testing goes in.
Yeah.
So I'll call it an injector.
Say one of Wayne's perfumes. Oh, sorry Wayne.
You know what? Chanel No. 5 and proud.
Yeah, that's good. So it has to be volatile because what we're going to do is heat it.
Yep.
Now,
Because this red thing.
That's an oven.
It's an oven.
That's why it's red, because it's hot.
The wire is a capillary tube. We'll talk about that more in a minute.
Yep. And as it heats, it vaporizes our subject, which is at a low boiling point, and then it travels through the tube, hitting our detector and our computer bob, and that tells us how long it took to go through the tube and what came through. When.
Detector and a plotter. Let's call it a plotter. It's some sort of computer.
Yeah.
And plots a graph.
Basically, gives us a graph at the end. So, there's
Take my perfume.
Yep. Put it in.
And as it's then going to drip into an oven, and the oven's going to be at a heat where it will turn it into a gas.
Yeah.
Gas.
Very quickly. So as it vaporizes, it will go through our tubes. But let's zoom in on tubes.
Okay. The mobile phase, the thing that's in the cylinder, let's say it's helium, that's used to push it round the loop so it doesn't just stay in there as a gas. It gets pushed through and out the other side. So that's what that's for. What Triv's done is he's done a cross section of part of the capillary tube.
I have. On the outer layer, we'll have some sort of insulation.
Yep. That's useful because it's in an oven. Okay, so the oven's going to have varying heat.
Yeah, so we want it to stay relatively the same heat.
Yeah.
Then we have our stationary phase.
Now this can actually be a solid or a liquid. If it's solid, what's going to happen is as the gas goes through here, it's going to be absorbed onto the. It's going to have adsorption, not absorption.
Yeah, and that's important.
That's important.
And that will slow the different things, different amounts.
Yep.
Will make different times in the detector.
Yep. So if it's absorbed more onto the surface,
yeah, it'll be
it's
slowed
going to
down.
take longer to go through.
Yeah. However, it could be a liquid.
Yep. In which case, it's going to dissolve as it goes on its travel through here. Different things are going to dissolve by different amounts.
Yeah.
To give different times.
Now, what do you do with these times, William?
Well, firstly, they're called the retention times.
That's an important
That's
thing.
a marking point. Retention. So these times, different things go through different times, and this plotter, this computer, plots some sort of graph of time in minutes, because again, it's quite a lengthy process. So time in seconds, not a lot would happen. It's in minutes against adsorption. And you're going to get various peaks. So lots of things will have a particular retention time. And, you know, things like what Triv's drawing there.
Like lots of sausages. That's not very clear, because the pen's running out a bit, so I'll do it in... okay, do it in black.
Yep, hopefully that works.
Yeah, that's a bit better.
So it's going to have different peaks, it's going to form a graph like that. And you can look at your other data and suggest that at different peaks would be certain things, perhaps if it's a perfume, a ketone, or an aldehyde, and alcohols, so the shorter chain ones are pretty volatile.
Yeah, so
methanol and ethanol.
Like in your book, like enough for your book, we'll have set things that we'll be able to look at. There is, however, problems with it, as there always are.
There is. What if things had the same peak, but one thing had a higher concentration? So say in my Chanel No. 5, there was a very high concentration of a ketone that gave a peak. But there was also a certain type of aldehyde that gave the same peak, but there was much less of it.
So basically it would have shown a little thing like this. But because of this is here...
massively overshadowed, you wouldn't suspect the aldehyde was there.
You wouldn't be able to see it. It basically hides.
Yeah.
Very sneaky.
A lot of things also have the same retention time, it's just a problem in general.
Yeah, which means you can't really tell them apart.
So say the aldehyde and the ketone had the same retention time and there were equal concentrations, it's not so much that it's been masked, it's just you wouldn't be able to distinguish between the two, it would show as one peak.
Which would be a problem there. And
the same as before,
Yeah.
if you've got nothing to compare it to, if it's a brand new chemical or functional group, then
then you won't know what it is.
yeah, if there's nothing to compare it to, it means nothing.
So like before, we mentioned that you should use it with different techniques, and we do this quite a lot.
Yeah, this one, unlike the thin layer chromatography, there is a thing with this that is used all the time.
Yeah, and we use it with mass spec.
Yeah, mass spectroscopy. And it can be useful in a variety of things.
Yes, finding out what was in someone's luggage, if they had something to
Yeah,
things.
so airports will all have stuff that sort of scans it and does stuff if there's anything dodgy going on.
And forensics, very useful.
Yeah, forensics. And then there's drug things, so athletes and stuff are tested for certain steroids and stuff.
Yeah.
And just drugs in general, you can test paracetamols and that sort of stuff and test things.
And in the exam they often talk about something called GCMS. Now that's just the combining of them. They have all, oh yes, gas spectroscopy.
Gas chromatography.
That one is good, and mass
Mass
spectroscopy is
spectroscopy.
good. So let's call this thing.
Gas chromatography, mass spectroscopy.
They were very
So
imaginative.
very imaginative. And you might be asked to know why it's useful to put them together. This separates them, but doesn't really distinguish functional groups and stuff.
Yeah.
Whereas mass spectroscopy doesn't separate, but it does distinguish.
So
when you put them together,
they're like the best of both worlds.
yeah, and it's used quite a lot of places, as we've said, airports and stuff. Very useful.
Very useful indeed.
And that's chromatography in general over the last two videos summed up, and this was gas chromatography in one video summed up.
Ta-da.
There you go. So I don't know what's next in the chapter, but let's get a cup of tea.
Oh, good plan.